currently this latency is around 300 microseconds, which I know sounds pretty fast, but not in the AI world. The way they solved it is actually pretty simple. They just increased the speed of our Thunderbolt connections. And I'm not talking about going from Thunderbolt 4 to Thunderbolt 5 and doubling that bandwidth. No. The metric we're looking at is latency. How quickly a packet or a message can go from MAC to MAC. Now currently this latency is around 300 microseconds, which I know sounds pretty fast, but not in the AI world. And because of this latency, we were stuck with something called pipeline parallelism. It's essentially a technique we use to split up a model between multiple systems and a cluster. For example, let's take an AI model like the Llama 3.37dB, FP16. A model like this will have around 80 layers, which essentially is a series of filters that your prompt will pass through to help it respond to you. So if you say, hey, what's the capital of Japan? Each layer is doing some fancy math on the input and passes the result to the next layer, each layer refining the answer until you get your response. Now, when you cluster this model, it divides up the layers between each machine. So Mac 1 would get layers 1 through 20, Mac 2, 21 through 40, and so on. But here's where it gets painful. It's sequential. So for every token, Mac 1 processes layers 1 through 20, stops, sends the results to Mac 2. It'll process layers 21 through 40, stops, and then so on. It's like a relay race with really fast sprinters, but we're not working together. Pipeline parallelism is awesome because it gave us capacity. We could run large models that we can never run on one machine and run them on multiple, but what it didn't give us was speed. Instead, we got a waiting room.